Hey guys, this is Mrs. Drake and
Miss McHenry.
And today we're talking about graphing quadratic equations. So we're bringing it kind of back to that first lesson that we did where we kind of introduced you to that fancy equation, y equals x squared plus bx plus c. And we talked about how this is called the standard form equation. And then there was also a factored form equation as well. And that was like our double parentheses guy. And how both were related to the exact same equation, they were just different ways of writing it. Now, I want you to remember, because we're going to be graphing today, that when we graph a quadratic equation, we know it's quadratic because of this x squared term, that's our highest exponent. When we graph it, we always end up with a U shape for a graph. That's called a parabola. Remember that fancy word? And that parabola could either open up like a happy face or down like a sad face. So we're going to talk all about factored form, standard form, and graphing using those forms today. So to start off, we've got this graph here. And I have the standard form equation written out, y equals x squared minus 2x minus 3. This equation actually tells us a heck of a lot of information because what's going to happen is we're going to give you the problem, y equals x squared minus 2x minus 3, and you have to graph it from that. So we won't give you the graph even though that's what you see here. We're just going to show you how that's related to the equation. So one of the fancy things that we can figure out from standard form is, does it open up or down? In other words, is it a happy face graph or a sad face graph? So the piece that tells us that is the x squared piece. So right now, that x squared piece is a positive. If it were a negative, we'd see a little negative sign in front of it. But in this case, it's positive. And if it's positive, then our graph's going to open up like a happy face, and that's like the graph you see. And if it was negative, then our graph will open down like a sad face. So that's just one piece that we can easily see from the equation. Another piece that we can see from the equation is the y-intercept. So I want you guys to remember that a y-intercept is where our graph actually crosses the y-axis. So if I were to write out the ordered pair of that y-intercept, it would be 0, negative 3. So our x is 0, and, x is 0, and our y is negative 3. Now the reason we can see this easily in the equation, if I know a y-intercept always has an x value of 0, then I can go back to my equation, and I'm going to actually plug in 0 for my x value. So when I do that, I get 0 squared, which cancels out is 0, minus 2 times 0. Well, 2 times 0 is 0, so that cancels out as well. And we get y is equal to negative 3, which we would have seen right here. It was our constant, remember that's a number without a variable, in our equation. So we can very easily see, we don't even really have to do a whole lot, we can just see in our equation the y-intercept. So I'm going to hand it over to Miss McHenry, and she's going to talk to you about two other important things that we can see using standard form.
So we're going to talk about two parts of the graph that Mrs. Drake didn't talk about yet, and the first one is called the axis of symmetry. And what the axis of symmetry is it's basically a vertical line that cuts the graph in half. So if I was going to look at it here, I see that this line right here, and we always draw it as a dashed vertical line, cuts the graph in half so that if I folded it over, it would fold on top of itself and be the same. The way that we find the axis of symmetry is with this equation, x equals negative b over 2a. And the b and the a both come from the coefficients in my standard form equation. So the negative b is the number in front of the x term, or that middle term. So right here, I'm circling this. Negative 2 is my b term. And when I plug it into my equation, it goes negative b. So it's negative, and then whatever b is. And in this case, that happens to be a negative 2. So there's a double negative there, which is okay. All over 2 times a. And a is the term in front of the x squared. Now, if you look here in front of the x squared, there is no number there. So that's going to be the invisible 1. So it's over 2 times 1. And then when I simplify this here, negative, negative 2, well, negative, negative cancels and makes a positive 2 over 2 times 1, which is 2. And 2 divided by 2 is 1. That is my axis of symmetry. And when I go over here and look at my graph, the axis of symmetry is over 1, where x equals 1. So that's how you find the axis of symmetry. The second thing that we are going to find is what we call the vertex. And the vertex is the turning point of the graph. So in a graph like this one, it's the very, very bottom of the graph before it starts turning back upwards. Or in one that has a negative leading coefficient where the graph is upside down, it's the very, very top of the graph. And if you notice, the vertex happens to be on the axis of symmetry right here. And it looks to me like that is at the point 1, negative 4. So we're going to go ahead and see if that works in our equation. So since the vertex is on the line of symmetry, or the axis of symmetry, where x is 1, we're going to take our equation and plug in 1 for x. So here is my equation. So x squared, so I'm going to do 1 squared minus 2 times 1 minus 3. And I'm expecting to get negative 4 out of this. We'll see if we're right. 1 squared is 1 minus 2 times 1, which is 2, minus 3. And 1 minus 2 minus 3 is negative 4. And that gives me my point right here where the x value is 1 on the axis of symmetry and the y value is negative 4. That is the vertex.
All right, so we've talked about standard form, and standard form is very useful. It tells us a heck of a lot about the graph. But factored form also tells us a lot about the graph as well, and some really important pieces. So I have here written my standard form equation, and I rewrote it because we're actually going to change it to our factored form, meaning I have to factor it. So recall like our little diamond puzzles, if that was useful for you. So I have my diamond puzzle, and I know that I'm looking for two numbers that when I multiply them gives me my constant, negative 3. And when I add those two numbers, it gives me my middle term, which is negative 2. So I'm going through and I'm like, okay, what two numbers multiply to give me negative 3 and add to give me negative 2? So I think negative 3 and a positive 1, because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So I can now write my factored form because I found my two special numbers. And remember, my factored form has those double parentheses with our x's here. And our two special numbers that we found, the magic numbers, were a negative 3 and a positive 1. So this factored form equation is directly related to our standard form. They're the same exact equation, they're just written differently. One's standard form, the other's factored form. So now that we've got our factored form equation, I'm going to erase this stuff so I can do some work here. We're going to see the super fancy thing that we can get from factored form, and that is our x-intercepts. So in this case, we have two x-intercepts. An x-intercept, if a y-intercept is where the graph crosses the y-axis, an x-intercept is where the graph crosses the x-axis. So I'm going to write my ordered pairs here. This ordered pair is negative 1, 0. And this ordered pair is 3, comma, 0. So if you notice in both of my x-intercepts, the y value is 0. So if I go to my factored form here, I have two pieces that contain an x. So that's telling me that I'm going to probably have two pieces for an x-intercept, two x-intercepts. So I'm going to set this first piece equal to 0, because we want our y equal to 0. And I'm going to set the second piece equal to 0. So I now have two equations, which makes sense because I'm going to have two x-intercepts. So now I'm going to solve my first equation. I want x by itself, so I'm going to add 3 to both sides. So x is equal to a positive 3. Oh, that's what we got for our first x-intercept.
Weird.
I know, right? It's like math.
Magic.
Magic. And then for my second equation, I need x by itself, so I'm going to subtract 1 from both sides. And that cancels out, and I get x is equal to negative 1. Weird. That's totally what we got for our other x-intercept. So, few more steps to find that piece, but our x-intercepts are so super duper important for our graph, and we can find them easily if we just have the factored form equation.
So we're just going to do a really quick recap. These were the two equations that we used, which happen to be one and the same. The first one was standard form. And it's written out x squared plus bx plus c. And the one with the two sets of parentheses is called factored form. And we found quite a few pieces of information from the standard form. The first thing that we found was whether the graph opens up or down. So you look at the number in front of the x squared, right here, and if it's positive, it's going to open up, and if it's negative, it's going to open down. This is just x squared, so it's positive, which is why the graph opens up like this. The next thing that we found was the y-intercept. The y-intercept is when the x value is 0, or where it crosses the y-axis. That is this right here, where it crosses the y-axis. And that's at negative 3. And we found that from the constant term in our equation. So we plugged in 0 for x, and we happened to get the constant term, and that works every time. Woo. The next thing we found was the axis of symmetry, and that is the vertical line that goes halfway through the graph. And the way that we found the axis of symmetry was with the equation x equals negative b over 2a. And we plugged in the values for b and a that we found from our equation. And then we found the vertex, and the vertex occurs on the axis of symmetry. The vertex is also the turning point of the graph. So once we found that the axis of symmetry was at 1, we plugged in 1 to our equation to find the value of y for the vertex.
And we also call that vertex for this graph a minimum, because if you notice, that's the lowest point on our graph. If our graph were a sad face graph, then our vertex would be a maximum, because we'd have a very high point on our graph.
Good. Okay, and then the very last thing that we did was we used the factored form to find the x-intercepts, and the x-intercepts are super duper important, and you will find out more later. But the x-intercepts occur when the graph crosses the x-axis, and that is a y value of 0. So what we did was we plugged in 0 for y, and we set each of those parentheses equal to 0 to find out where they cross the x-axis.
Yep, and just solve for x in each case.
Yep.
Woo!
All right, and that is the end of our video for today.
And we're going to do some little guided notes to have formally in your notebook so that you have a really good reference point for tonight when you do your homework. And let's go graph some quadratic equations.
Woohoo!